Greetings to everyone. My name is Jay Chinaranga. Currently, I am pursuing my graduation in BTech first year of EC department. So, in the VCA to video representation, the topic which I was assigned to give is preparation, properties, and applications of Teflon and PVC in engineering chemistry. So, let's get on to the topic. Preparation of Teflon. Sorry, the properties of Teflon. So, what is a Teflon? Where the property, how the properties of the Teflon looks like in the physical, chemical, and thermal properties. So, let's know about them. Physical properties. The Teflon has highest high melting point of 327 degrees centigrade. So, it has a high melting point such that high melting point such that it is very resistant towards heat. It has a very extremely low coefficient of friction and excellent electrical insulation capabilities. Due to for example, we can see that in our day-to-day life there will be some of the wires which will be used in household appliances, household applications. The material which will be guarding the electrical wires or plastic like substance called as Teflon, because it is very it works as an insulator. It is an excellent insulator of the electricity, so it can be also used as the guard of electrical wires. And chemical properties, highly resistant to most chemicals and solvents. So due to this property, due to this property, it will be used in a burette. It will be used as a burette in as a stopcock. It will be used in burettes as a stopcock to release and stop the solvents. And non-reactive with the most substances. It does not, or it is not at all reacts with many substances, and it is inert to corrosive materials and acids. So it is also not corrosible, and it has some of the thermal properties such as wide temperature stability range from minus 200 degrees Celsius to 260 degrees Celsius. It maintains properties at extreme temperatures and excellent thermal insulation and characteristics. So next we can learn about the, so let's get on to preparation of Teflon. So this is the preparation method of the Teflon. Chloroform CH3L3 will be reacting with 2HF, which gives rise to chlorodifluoromethane in the with the byproduct of hydrochloric acid. And these chlorodifluoromethane is taken 2 moles, and it is undergone at a pyrolysis. It gives Teflon, I mean tetrafluoroethylene with the byproduct of hydrochloric acid. And these tetrafluoroethane will be will be undergoing polymerization in the presence of benzyl peroxide of n moles, will be given as Teflon. Longest chain will be formed, that is called as a Teflon. And the properties and now let's get on to applications of the Teflon and PVC. A comparative overview of essential polymers. Welcome to this comprehensive exploration of two revolutionary synthetic materials, Teflon, polytetrafluoroethylene, and polyvinyl chloride (PVC). This presentation will examine their unique properties, manufacturing processes, diverse application, and environmental considerations that make them indispensable in modern industry, medical and industrial applications of the Teflon. So let's forget about that slide. And medical devices and implants, heart valves and vascular grafts for cardiovascular procedures. So we can see that in recent man invented a titanium heart, which will be given for the patients who are having the heart related problems. Until a donor heart is available, the real heart place will be replaced with that titanium heart, in which a Teflon is added, in which it acts as a heart valve. This is a recent news. And catheters and surgical tools with a non-sticking coating. So we can see that while cutting the skin or while making any operations, the skin will be so sticky. So to avoid this stickiness, we will be using the Teflon. And it will be also used in the cooking vessels as we prepare dosa or pesaretto or some of parota. With there will be somewhat non-stickiness. So these non-sticky, due to these non-sticky substances, the dosa will not be stick to the pan. And due to this stickiness, that above that temperature, above the melting point of the Teflon temperature, the Teflon will be also mixed in the food items, and it also causes the cancer. And biocontainment vessels for medical storage. It has some of the industrial applications, non-sticking cookware and kitchen equipment, as I said before, and chemical plant vessels and processing equipment, and as titanium heart and high performance. It has some of the key benefits such as exceptional chemical and heat resistance, low friction and non-sticky properties, biocompatible and safe for medical use. So now let's get for PVC. PVC Introduction and Synthesis. Understanding the versatile synthetic polymer. Polyvinyl chloride. PVC is also abbreviated. PVC is abbreviated as polyvinyl chloride. Consists of repeating units of vinyl chloride monomers. It is discovered in 1872 by Eugen Baumann, commercialized in 1920s. Synthesis through suspension, emulsion, or bulk polymerization methods. Raw materials include ethylene, chlorine, and vinyl chloride monomer. Manufacturing involves polymerization at 40 to 70 degrees Celsius under pressure. Additives like plasticizer determine final product cash preparation of PVC. Preparation of PVC is very easy, and to prepare polyvinyl chloride, we first of all we can sorry first we have to know that the monomer units in polyvinyl chloride are vinyl chloride. So to prepare vinyl chloride, we have to use acetylene. Acetylene reacts with hydrochloric acid to give vinyl chloride, and these vinyl chloride is taken n moles and polymerization, and it is undergone polymerization to form polyvinyl chloride. Properties and characteristics of PVC. Physical and chemical properties. It is available in rigid and flexible forms through additives. Excellent resistance to acid, bases, and solvents. Due to this excellent resistance towards acids, bases, and solvents, it is also used as pipes in our day-to-day life. And applications of PVC. Construction materials. PVC pipes and fittings for plumbing systems. As I said before, it is very resistant towards the solvents and acids and bases. It is also used as a pipes. We have to say that in our day-to-day life, PVC pipes are used in most of the applications. And window frames and the door profiles and vinyl flooring and the fall covering materials are also there. Consumer goods, raincoats, shoes, and fashion accessories. As we see that in a rainy season, most of the people use umbrella, raincoats, and many of the water resistant materials which will be guarding them from the solvents, and those solvents are made up of polyvinyl chloride. Children's toys and sports equipments are also made of PVC. Home furniture and decorative items, such as in our birthday functions and marriage functions and engagements, most of the applications there will be PVC. Healthcare products, blood bags and four fluid containers. As we see in movies, when we go to donate the blood will be stored in a packet, somewhat in a rectangle shaped packet. That packet is called as blood bag, and these blood bags are made up of PVC. Medical turbing and catheters, protective medical packaging and gloves. These gloves are also made up of PVC while using in surgeries. Electrical and packaging. As we seen in the applications of the Teflon, where the Teflon is going to guard the electrical wires by using the surrounded by a plastic substance called Teflon. And as Teflon, PVC also guards the electrical wire, which is also somewhat resistance towards heat, such as low resistance, which will be used as a small low wattage bulbs, which will be used for small experiments in our engineering colleges, which will be not at all dangerous. And food packaging and blister packets and protective covers and electronics. Thank you for giving this opportunity.